How you doing, everybody? Randy Richard in the shop. This is where we left off on the Fusion engine. We have our base completed, we have our cylinder itself completed, and we added motion to the cylinder. Now what we're going to do is we need a pivot shaft to go through the base out here, and it attaches to the cylinder. It's made up of several parts, though. What I'm going to do is we'll get the two main parts done in this video. There's a lot of little features we're going to add, and a lot of new stuff here that we haven't shown already. So every drawing, every video, there's going to be something new, pretty much. As we get nearer the end, there won't be as many new things, but especially in the beginning here, there's a lot of new stuff we're going to cover. And in this video, I'm going to not cover every which way to do some of the things because it'll make the video really long. So we'll do one way in this video, and then in the next video we'll do some of the same thing, but we'll do it in a different fashion so you could see the different methods of each thing there, especially when you make patterns and things like that. So to make drawing and modeling a little quicker. So we're going to get started here. We're going to, like I said, make the pivoting portion for the cylinder. Now, since it is kind of part of the cylinder assembly, you would say, I'm going to make the parts for that within the cylinder component. There'll be separate components, but that way you're kind of making a sub-assembly within the complete total assembly. And so what we're going to do is we're over here at the left, we're going to select cylinder and make it the active component. And so we don't really care about the base anymore. So we're just going to hide the base and only have the component out here, right? And if we turn on the origin for the cylinder, you'll see it's still there in the center because we moved everything and aligned everything with that point. And it's going to be very helpful here in making and modeling the pivot portion of this. So the main two parts here of the pivot are the base feature, the base part of it, and the screw itself. Now the screw is actually, or the rod, the shaft, whatever you want to call it, is made from a 1032 socket head cap screw, a standard 2-inch one. First off, what we're going to do is we'll make the little piece that sits in this recess here on the cylinder. And it actually is pretty easy to do. It's gonna fit right in here. It's also going to end up with 4 clearance holes for the 432 socket head cap screws to pass through. So first thing we're going to do is make a new component within the cylinder. So we're going to right click on the cylinder and get our list. Now, before, what we did is we right clicked on the entire assembly, the entire model, right, the whole engine, and made the components. So we have a base component and we have a cylinder. But for this, like I said, we're going to make this its own little kind of separate assembly. So we're going to right click on cylinder and create a new component within it, and we're going to call it since we know it's within the cylinder, we don't have to use the word cylinder. We could use pivot rod base. Pivot rod, that doesn't sound good. Pivot, we'll just pivot rod, yeah, I don't know, base. Until we think of something different. I can't think of something different right now. That's fine. And now when you click here, you have its own origin even, right? So we'll just turn on its origin. We can turn off the other one. and it's going to be in the same location, right? And we're going to continue on making sketches and drawing. It's pretty simple. And first off, and you know your origin is, your XY plane is on this flat surface of the cylinder, this rectangular flat surface, and that's perfect. So we hit S again, create sketch. We've already added create sketch to our model shortcut. And we need to pick a plane to make our drawing on, right? So we're going to come up here, and there we go, XY plane. That's what we wanted. Perfect. Now we turn, it's turned to be normal to us. First thing, it's going to be a circle, right? Now I could have projected the circle, but I'm just going to draw it for now. We're going to do some projection stuff anyway. So, but for now, we're just going to draw the circle to make it easy. Get it started in the center, of course, and the diameter is 0.7. Now, normally you would project that because it's maybe a little quicker and easier, but it's like 6 of one, half a dozen of the other, what you might want to do. Now we have a couple choices we can make here. We can extrude this as a disc, but there's other things that go with this disc. We're going to end up having to put a hole in the middle. So we're going to do that right off the bat, okay? So I haven't talked too much about the 3D cube up here in the corner that you can grab, and it moves your piece around and it shows a pivot point. Up there in the corner, if you just hover your mouse around, you get all sorts of little options, like it turns blue, right? So if I click on blue, that's going to turn that face to me normal. But I also could click on an edge. See how it turns blue? And that would flip it so it's that corner's at me type of thing. Or I can go right here to the back side and click on these little arrows. It turns at 90 degrees in that direction. Or if I want to rotate it, I don't want the orientation. I want it to still be normal to me on the end, square, but I could just rotate it in one direction or the other, right? So you can get to normal positions pretty easily. And this side here we're working on is the left side. There you go. So now we have our back normal to us. So let's put our center hole. C for circle. Click on the center, and the center hole 0.1875. It's 1875 because that's the diameter of a socket head cap screw, the number 10. And that will be plenty of clearance. Most of the socket head cap screws are 1 or 2 thousandths even under that, so that's plenty of. We want it to be a pretty close tolerance. All right, now we're ready to do an extrude on it. We'll stop the sketch. Click on that, or E for extrude. That's the surface. We want the donut. We don't want the center. In 1/8 of an inch. And you can just, it's a minus 0.125. There we go. And now we have a nice little disc in there. Now it needs a counter bore from the other side. So you can just turn this a little bit. You can hide the cylinder if you want and just click on the little light bulb. But oh, that's going to go away, see, because it's all part of the cylinder. All right? So you gotta kind of watch out what you click on. Here, if you do the component, it's going to turn off everything underneath the component. But if you go down here into bodies, the body of the cylinder, you can just click on the light bulb for it and only turn it off. Okay. So S for the shortcut one, create sketch, this side. C for circle, for the counter bore, click on the center. Now, like I said, I told you about the app iEngineer. I use that on my phone. And so I looked up the 1032 socket head cap screw and found out the diameter of the head, and it's 5/16. So we're going to put 3-1-2-5 in there for 5/16. Nice standard size. Could go right in there with the end mill and bore that out, make it nice and easy. There we go. Stop sketch, and we'll E for extrude, and we'll extrude this down 0.94. Oops, minus 0.94, and it's a cut. And now we have our counter bore. Okay. Now we need to have 4 clearance holes in here, and they need to align. They're going to need to be the same orientation, I should say, for alignment into the cylinder. So let's turn the cylinder back on. Hit the light bulb on the body again under cylinder so we can see it. Now we're going to do what's called a project. I can just go onto this cylinder side here if I wanted to and draw 4 new holes and all that into the proper position, because we used a standard 45-degree offset orientation and all that. But what's sometimes very helpful, it's not necessarily easier, but it's very helpful. You can do what's called a project, and we can project the holes that we drew in the cylinder out onto the surface of this disc, so we know the exact location. We could even use those projections to extrude holes, but they're going to be too small. They're not going to be the size we need. We need to be 0.120 for a clearance hole, where the other holes are 0.089 roughly. So, but we could still use them for positioning. So we can say, we can just say, you know, shortcut, create sketch, and we'll click on that surface. Like I said, but now we want to project those screw holes up there. So we get it turned to how we want, and then we're going to hit P for project. Now we need to select geometry, and there as we highlight, that's that there, and those 4. We don't want the single one, we want all of them. So just click on that. Now we've projected that out to that surface that we had for our sketch. And we can say, okay, you see over here on the right hand side, the projection dialog box, and say okay. Now we don't see it because we projected it to the piece we turned off, so we can turn it back on again. And there we see the purple projected lines already there. We didn't have to figure out where they are or anything. We just build off of a previous piece, which makes it really nice and easy. Now that we have this projected, we'll do the C command. We're just going to click on here, 0.120. Now we have that circle. Now we're going to do the circular pattern thing again. Select the circle. This is just like we did before. Center point will be there in the center. It gives us 3 circles, but we want 4. Change that. And we have 4 circles centered up. Okay. Stop sketch. We'll do an extrude, but we need to extrude the whole thing. So make sure you get all of it selected there, so that the whole is complete. We're just going to come over to the other side, select the back surface, say it's a cut, say okay. And now we have our clearance holes, and they are all lined up perfect. And of course we've already have our counter bore. So everything's done on that little part of it. Now we need the screw. Now there's really a couple ways we can do this. We could build it in little sections and a lot of sketches. We can do the revolve. We can draw the profile, which is, I think, the easiest, and do a revolve. Or we could actually import a screw and modify it to make it work for us. But sketch it, in this case, we're going to draw the screw and do a revolve type setup. But we'll make it another component within the cylinder. So we can select the cylinder again and right click and say new component. Or do we make it a component right here with the rod base, because it's really part of the rod? See? So let's do that. Let's make it a part of this. And we'll say there, we'll right click on the pivot rod base and say new component. Click on that again and we'll call it the rod. Okay, you can see how we're just building along. And we don't need to see the cylinder anymore, so we're going to go back here to the cylinder body and just click on that and get rid of the cylinder. Now there's our part that we're going to draw into. So S again, create sketch. What sketch plane do we want? Well, the back side of, or I should say the front side, I guess, the front side of it is on the XY plane. But we want to draw along the axis, the Z axis, so the screw comes out, right? So we want to really choose the Z here, the YZ plane. And we're just going to click on that, and we have the YZ plane selected. Now we're going to leave that there because it can actually help us a little bit. So the screw is a standard 1032, 2 inches long socket head cap screw. So we're just going to do a line, and we're going to draw the center to set our length kind of thing. And I'm just going to start right in the middle, out here past our disc, and draw a line. Okay, it's actually longer than 2 inches because the bottom part of it's 2 inches. It's actually going to be 2.094 inches. How do I know that? Well, I know that because what they did here is they took a socket head, standard socket head cap screw, and they cut down the top of it to fit in this recess. And the recess is 0.94. So the top of our screw is going to be 0.94. From the bottom of the recess out is going to be 2 inches. That's how I know. But we really didn't have to know the length, but we're just going to throw it on there for now. You'll see why. So this here needs to be right with this line. And then I can go over here and type on coincident or constraint on the right and click on the end and say I want it coincident with this line. And it will move the line over, but it maintains the length because I had already dimensioned it. That's why I wanted to have a number on it. Otherwise, it would have just shortened the line. Now I can actually go in and put the proper dimensioning. I could say this here line, I'll get rid of that dimension, select it and delete it, and then I'm going to say dimension. But from the end here to this line, which is the bottom of the hole, I'm going to select on that, is actually 2 inches. And it's already came up 2 inches because we predetermined it. Okay, now we've dimensioned our line properly. It's coincident on the end, and the 2 inch part is 2 inches, and the head part is the little bit left. That's why, like I said, it really didn't matter what dimension we had on that line. We were going to make it the right dimension. Now we'll just draw some lines. A vertical line, okay, and then we're just going to come over here, draw a line to this, to the constraint line that was put in by the system, which is okay for now. And then we're going to go up a little bit, and then we're going to go over a little bit, and then go down a little bit, back to the center, I should say. Now we should have lines here, here, here. Well, we didn't get one there. So what happens is the system is putting in these projected lines, okay? And like I said, sometimes they're good, sometimes they're bad. Now, in this case, it's a good line in one sense, is that it picked the edge of the counter bore right there, which is a good thing, because that's really where we want this line. And we can just grab it and drag it. We could also say, well, we could say coincidence this here with that. Here, coincidence, and then hit the select only the end, and then hit on there, and it will move the line there. See, we don't really need to know numbers all the time. Only when you're starting a drawing and things like that do you really need to know those numbers, that kind of thing. You can make things line up from the previous thing that you drew, right? And that's what makes it parametric, and how things are related to others. So we have now this line here, but this line is too long and it will break our model. So do a trim, and we should be able to trim that. Well, man, maybe this line, this is a projected line, so it won't trim, but it will still kind of screw up our model. A lot of times what I'll do is I'll just delete them, because they kind of cause issues sometimes. And then sometimes they're hard to delete. There, now we deleted it. And then you got to redraw a line. Now this one out here is the same way. We might be able to make, no, that's going to move that. Anyway, so a lot of times I will, like I said, I'll just delete these things if I don't really need them. Now you see here the only line it's showing is the projected line. You can go in and draw your own line from there to there. Now when you come up here, it will select only that line. It's like a line on top of a line. And that's really what we want. So now we've got our, see, now when I select here, I have a profile of what I really want to represent to do a revolve. I don't know if it's, I mean, that was a lot of confusing stuff there, but that's why these projected lines can really kind of screw you up sometimes. And they're easy to just hit the projection thing there. It's selected, it will turn blue. That's your little projection symbol, and hit delete. And you can delete these constraints, and now it's really a line, and you can delete that line. Now the line you see there is the line from the workpiece. It's actually the outer edge of it. It's not a projected line. I've got rid of all the projected lines. That's why how I was getting at is that sometimes the lines are helpful and sometimes they're not helpful. But in this case, they were a little bit helpful to tell us where things were. Okay, so my dimension here, I lost it for some reason, is 2 inches. The dimension from here to here. Now this is a very handy feature. I don't really need to know the exact radius and have to do a calculation. I know that the diameter of a number 10 screw is 3/16, 1.1875, and I could put in 0.1875 divided by 2. I can actually put that formula in, and it will calculate it for me and set the dimension. Very handy feature, you being able to use formulas. And then we'll stay stop sketch. There we go. And then we'll do a revolve. Now I already have revolve on my toolbar, which is kind of nice. And then I hit there, select the axis, and we have a screw. New body, perfect. Say okay. There we go. Now we need to make it look like a real screw. Well, real screws are chamfered, so we're going to go to modify, chamfer, there. 0.02 is about right. That looks good. You can put a nice little chamfer on the end. And we're going to go up to create and select thread. Now faces. We want to thread this face, so we're going to select that. Default value is full length. Well, we don't want it full length. First off. Then we can set the length. Now we're going to make it, most of them about 1 inch. So we got our 1 inch of thread, and I'm going to talk a little bit here about the thread feature real quick. If you want to look, like I said, it puts a picture on normally, but if you want to look actual modeled, as long as you're not having to do any selecting of a feature off of this, having it modeled is fine. It makes the calculation for everything a little bit slower, of course, having to model all those extra lines. I'm going to leave this one modeled. For now, we're not really having to select anything off of it right now. So we'll leave it modeled so it looks good. Another feature here is offset. And you can plug in a number here and it will offset it from where these origin points are. And so I said 1/2 inch if you wanted to have the thread up in here, you know. But that's what offset does. In many cases, like on a hole, you might have that offset. And then of course you set the length of the thread. We set it at 1 inch, and we set the thread type. ANSI unified screw threads we'll use, and then we select the number 10. Of course, it figured out the number 10 off the diameter. Already figured that out for us, but we don't want 1024. We want 1032. 1032. There we go. And 3A is fine for class of threads. Right hand, and we'll say OK. So now it's nicely threaded. Now the one feature that's missing here is there will be a hex hole remaining. We don't really need it there, but there will be. And if you want to make it for aesthetics, would be shortcut S again and create sketch. We'll create sketch on the end. So this is a new feature we haven't talked about. We'll go to sketch and we choose polygon. Polygon has 3 choices here. Circumscribed polygon, where it draws the polygon on the outside of a circle or a diameter that you designate. Inscribed polygon, where the polygon is drawn inside, so that's the tips of the polygon. A polygon is a multi-edged, a symmetric multi-edge diagram or sketch. Edge polygon, that defines it by the length of the side of the polygon, just like these pictures show. Well, we know that using iEngineer, again, I looked it up, and the size of a hex key for 1032 is 5/32. So we're going to do 5/32 circumscribed polygon. We can click on the center. It says place center point. And the default is a 6-sided. And for us, that's going to be fine. Now we could change that to whatever we wanted. 100 sides, whatever you want. And you'll see here it's drawing a line, and that line is the number it represents is the radius of the circle, not the diameter. Well, again, I don't want to have to pull a calculator out or actually figure this out or even look it up. But I know it's 5/32. So again, I can put a formula in there. So we're going to write a math formula. Parentheses 5/32, 5/32, right? But it's divided by 2 because it's a radius, and 6-sided, and hit enter. Now I have a hex in the middle of my screw, the right size. Stop sketch, extrude. We'll make it a cut. And how deep do we need to go? Well, it's just what's going to remain, and usually the depth, total depth of a hex key going in is usually the same as the size of the key. So we've cut about half of the head off, roughly, and so it'd be about half of the 5/32. So it's only for aesthetics, so I don't care what it says. just as long as it looks like there's a hex key going in there. Because we machined off the end. So we're good there. I think we're done. We're done with that piece. Now let's bring our cylinder back. All right. Now there's a couple other things we're going to be doing here. Well, we have two components here. And in the previous video, we made a joint to lock these together. Because right now, if I grab this piece, I can move it. It's not, and if I let go, it will not go back there. It's loose. It was drawn in place. So I'm going to just hit undo command and put it back. It's the same with the little disc. If I grab the disc and drag it out of there, it's not going to stay there, right? It's going to move. So we need to make some joints. So we're going to hide. So let's first let's make a joint with the disc to the cylinder, its relationship. So I'm going to hide the rod. I'm just going to turn it off. I'm going to go back to cylinder as the basis of everything. And there's my disc sitting in here, the broad base and the cylinder. And everything's aligned, right? But we want it to be locked in with the cylinder. So we're just going to do a joint. And the first component is going to be this face of the disc at the center, right? And so I've got the base. I'm going to hold the control key, and I'm going to make sure, not the center of the screw hole, I'm going to make sure I select the center here. And then the second part is going to be the cylinder. I want to make sure this face, which I'm on, and see it's how it's highlighted in the dots. I want to select the center, not one of these little other points. I want the center to be aligned. Now, oh, it flipped it over. So what we're going to do is hit flip over here on the right and turn it back over. And we're aligned with a rigid joint, and we're good. Now it's solidly locked with the cylinder and aligned with the holes. And so if I move the cylinder in our rotation, what we have set up already, it will turn with it, which is what we want. Now we're going to put the rod in. So we're going to turn the rod back on, the little light bulb. We're going to set the focus to the rod, pivot rod base for the joint. We don't care about the cylinder right now anymore. We'll hide the cylinder so we don't see it. But if I turn off the cylinder like I just did at this level, I turn it all off because everything is underneath it. So we turn it back on. We want to just turn off we'll just turn off the body so we don't look at it. There we go. Now we want a joint to lock these two together. So we're just going to go up here to, again, joint. Now it's going to say capture position. Why capture position? Well, neither one of these are grounded. And in space, we haven't told it where they are. So we want to say, we don't want them to move to a different location or out of position and all that. Even though they're in where they're, if we hit continue, they should stay where they are. Let's do that. Let's hit continue. And they didn't move. Because we drew them with the axis, and we drew basically because we drew them at within the axis point. Because when you want to move something, it's going to move it to the axis or out of the axis. We didn't move it away from the original location it was drawn. Let me put it that way. We didn't move it away from the original location. So it stayed there. Every time you do a capture position, it puts another history marker down, and sometimes if you end up with a lot of those in there, it causes your history to move things if you scroll, and it can get very confusing. That's why if you could draw in position with the axis planes, things will not move around so much on you, and that could be a real problem when you have very complicated drawings or models. So let's, we're just going to make another joint again. We're going to select our first component as this one in the center. See, now it wants to select the hex. Hold down Control, select the center. If we get out here, the center outside, but I want that surface because I want that surface to align. So I'm going to hit the center. Then I want this surface, the center. Hold down Control and move over here. Now it flipped it, and we're just going to flip it back around. And we'll call that rigid. Good. Now it will move with the cylinder also. See here, if I can move. See how I make it rotate? See, everything, well, everything rotates. The hex, everything, right? You know, doing this joint stuff is pretty advanced stuff. So just so you know, if you can follow along with the joint thing, it's pretty good. Took me a while to learn all this. Anyway, what else we need? We're not done yet. We're going to put in the screws. We're still not done yet. We'll just leave the cylinder off. What the screws we're going to do, we're not going to draw the screws. So we're going to do an insert up here. McMaster Cars catalog is accessed through Fusion, which is really nice. There's a lot of fasteners and a lot of hardware that you can get and already modeled. So we're just going to click here on the screws and socket head cap screws. Now, you can scroll down. There's a lot of other choices here. And we're going to choose the steel socket head, alloyed ones, fine. And we're going to choose over here on the left side 440s. And these are supposed to be 1/4 inch long. And if you find the right for length here, 1/4 inch. Then you might scroll down over here. You got to select one of their part numbers here, like this one, 1/4 inch black oxide. Just like looking at their catalog online. Then it comes up product. Go to product detail. Then scroll down, and you're going to find actually there is a drawing. See right there. And you can go here, and you want to. Normally we'll start with SolidWorks, but I've already been using it, so you want step file. Okay, you want a step file. That works really well. Say save, and it's going to insert a screw for you, and it's going to insert right on the axis. Now it's not in the right place. Now over here there's a lot of move types. This is a free move type, and you move it. Just grab the arrows, or which way do you want to move it, right? You don't have to line it up here yet. I like to get it kind of lined up, so I'm going to pull it around and rotate it so it's 180 degrees. So we know it's all normal to things, and it's kind of close. Like I said, it doesn't have to be right on the money. There's translate, which it will only be those 3 axis movements, and then there's rotate, and then on this one there's point. There's actually another one, but anyway, point to point. It's a very, very handy one. So let's use point to point. And we're going to zoom in here and select this surface here is what we want. It's going to be flat against the base. So I want this. I'm going to select the circle and get on that. They're highlighted on that surface, and hit Control. I want to make sure I select that center. If you zoom in here, you'll see a little tiny. Let's see here if I get. See that little light X? It's really hard to see. And I want that center point there. I selected it. Okay, and then I'm going to come over here, and I want this hole, and I want the center. See how it drew that blue line? So that's where it's going to go. It's going to just, boom, move it right in there, point to point. And then I can say capture position if I want. I can do it right there. Capture that position. Now I don't want that, because I don't want that one to move, right? It's not locked in with a joint though. I can still move it. See? I can still grab it and move it. And now I'm just going to undo that move. So let's make a joint for it. Now let's lock it in there. Now, this is where the as-built joint can come in pretty good. As-built joint, it's in place already, And I'm really not going to do any rotational stuff or anything fancy with it, even though I can change it, but I'm not going to. So I'm just going to select the screw and this and rigid together. It's done. Now, I put in one screw and it made a component underneath this component, which is perfect. Now, how do I get the other ones? There's several methods to this, and one easy method though is to do right click on the screw. See, it has the part number down here. Now you can rename that if you want. Right click on it and just say copy or Control C. It's like every other program, right? And then right click out here in space and say paste. Now it will put it right in the same place as the other one. And then you could drag it over here and try to get it lined up, but you know what? A lot of work. Hit point to point. Get your either the circle or the surface. Hit the center. You can see it right there. Pick a hole. That's where I want it. Done. Say okay. And then do a as-built joint. Same thing, lock it in. There you go. Now they're locked in place, and they'll turn with this, right? Now they're all locked in place. They'll move with this. Oops. Okay. We'll back up. Let's turn the body of the cylinder back on. Let's turn the base back on. All right. Let's give focus to the entire assembly, and we have our whole engine back. We have our cylinder, and when we move this, you can see the screw turning. It barely, but it's turning. There we go. I think that's enough for this video. It's gonna be kind of long. A lot to absorb there. But all very doable. Really, as long as you just think about it a little bit and follow the steps, it's really pretty easy to do. Now, nice thing here, we can let's make our base opacity a little lighter. Let's make our cylinder opacity light. And what we can do, it's a little complicated, but we can look in here. Let's look from the top. We can see the screws inside the recess, and you can see whether there's a clearance from the top of the screw in the recess of the base, and there is. We can measure that if we wanted to, and as you rotate that, you can see it. And we can see where our screw goes. We haven't put our bushings in yet, which we'll do. All right, you guys, thank you guys. Thanks for watching. And in the next video, we'll be able to finish up the pivot rod. We have a spring, we have nuts, and we need to put some bushings in on the shaft here. So we'll do all those next in the next video. And then the video after that, we'll have to finish up the cylinder heads, I think. And we still have piston rods, crankshaft, all that to do. I want to get all the piston inside done first before we move on to the crankshaft. All right, you guys. Thanks for watching. And please, tune into the other videos in this series and the building of the engine series. I think they're kind of fun. It's a fun project. You could design your own and build your own. It's very satisfying work. It's very satisfying to end up with something that you designed and built yourself. So, thank you guys for watching. Please subscribe and check the notification bell so you can get notifications. I'm doing these fusion ones once a week, the build ones once a week, and it's going to take a little while to get everything done, but we'll get it all done. Thank you guys. Thanks again.